Welcome back for another edition of naming compounds and how to write formulas. Polar bears and polar cubs, we're going to talk about acids. So, acids, all acids have the same cation, and that cation is hydrogen. So, if you see something that has hydrogen in front, it is automatically an acid. Okay, so since hydrogen is the cation, we need to name it off of the anion. So we have a nice little flow chart below. You're going to want to write this down. So if the anion is "ide," meaning that it would be from the front of the periodic table, you're going to add the prefix of hydro. You're going to have the stem of the name, meaning you're going to drop "ide." You're going to end the ending of "ic," I-C. So, for example, if you had HCl, this is hydro, chloric, and then acid. Another example would be ite. So if you have ite, these are polyatomics with one less, or it could be two less, and you'd still have to keep the prefix of hypo. So these are polyatomics. Okay. So we're going to drop the ite and make it us. So for example, you might have HClO3, and this is going to, oops, that would be an 8. So let's go to an ite. That would be ClO2. Okay, this would be chlorus acid. And then finally, what if we had an 8? So this one is going to be HClO3. So that's chlorate as the anion. You drop the 8 and you add the ic. So this becomes chloric acid. Now, you might be looking at it and being like, Mr. Day, hydrochloric acid, chloric acid, they have the same ending. There's a prefix. Yeah, but look at the difference. Hydrochloric acid, HCl. Chloric acid is HClO3. So, there is a difference. You need to make sure that you're not seeing hydro and thinking that it has an H, and that's why. The hydro is there because it's from the front of the periodic table. So let's move on. Now, we're going to go through some of these examples. So HBr, the anion is Br, so that would be a ide ending. So because it's an ide, it's bromide. It's bromide, so you're going to change the ide into ic and add hydro. So you become hydro bromic acid. It's one of the more bros of the acids. All right, let's go ahead and try the next one. I'll have you guys try the next one. We'll see answers in 3, 2, and 1. The name of the anion is nitrite. Okay, so the new ending would be us. No prefix, giving us the answer of nitrous acid. All right, go ahead and try the last one. One more. 3, 2, 1. CO3 is carbonate. It gets a new ending of ic. It gets no prefix, giving us carbonic acid. This is probably the acid that people deal with mostly on a common basis. You guys ingest this acid all the time. This is pop. Okay, so H2CO3 is how they get carbonation within pop. All right, before we move on to these, to the writing of the names, I do want us to, I have some shortcuts. Okay, so I have some phrases that could help you in remembering kind of what to write. So the first one, for those that have "ide" as the ending, it is my ride has hydraulics. So let's know. "Ide" goes to hydroic. The next one, Sprite, is delicious. Ite goes to us. And the very last one is I ate something icky. Now, the reason that I say icky and you might say icy is because ick is the end that we're looking for. So ate goes to ick. And those are my three phrases that really help students keep in mind what endings go to prefixes and the new endings, or what new endings would then go back to the anion ending. So let's go ahead and let's name some acids. So the first thing is, remember that you just need the charged number of hydrogens. The crisscross method still works here. Hydrogen is always going to be written first, followed by the anion. So nitric with no prefix goes back to 8. So I'm going to write nitrate. So that's NO3. It's got a -1 charge. Hydrogen having a +1 charge, crisscross them. And your final answer is HNO3. Example number 2, you have hydrochloric acid. Well, hydro and ic becomes ide. So it's chloride, which is Cl with a -1, H with a +1, crisscross, and you get HCl. A good thing, good reminder for hydro is hydro means no O's. Hydro, no O's. Finally, we have chlorous acid. Chlorous, us goes back to ite, so chlorite is ClO2 minus, H again with a +1, crisscross them, and you should get a nice HClO2. There's one more example that I would like to do that's not on here, and that is oxalate, acylic acid. Okay, oxalate on the back of your periodic table is Cl or C2O4 with a -2 charge. You have H here with a +1. 2 is going to come down, 1 is going to come down, and you should have H2C2O4. You cannot reduce that. All right. That has been writing formulas of acids and naming acids. However, there are a few special cases. So, special case number 1 has to do with all sulfur acids. Okay. And all it is instead of changing any of the words or dropping endings or anything like that, we always start with sulfur and then we add our prefixes and endings. So, for example, on this one, it would be sulfide. However, you're going to start with sulfur. It has no O's, so it must have a hydro. Sulfuric acid, so it becomes hydrosulfuric acid. SO3 is an ite, so it becomes, the ite ending is us, so it becomes sulfurous acid. SO4 is sulfate. 8 gets the ic ending, so it becomes sulfuric acid. The second major exception is those that deal with phosphate. And with phosphate, what we're going to do is we're going to use the phosphor. Okay, so we're going to drop the us off of phosphorus and use that for everything. So when it's just no O's, this gets hydro and ic, so it gets hydrophosphoric acid. And then for phosphate, again, you add the ending of ic after you've dropped us, the us, so it becomes phosphoric acid. And then finally, this last one, it's not really even an exception because really we only write it one way, and that is HC2H3O2, which is acetic acid, which is based off of acetate on your periodic table on the back. All right. If you have any questions, let me know. Otherwise, best of luck on your worksheet.